Welcome, dear student. This text shows the exact wording of question 1 from the WAEC 2026 Mathematics exam. It asks us to calculate the height of a vertical pole using a given angle of elevation and a horizontal distance. To solve this, we start by turning the words into lines. Here is our vertical pole, which we will call h for height. Extending directly from its foot is a horizontal distance of 10 meters. Now we close the shape. The question gives us an angle of elevation of 55 degrees. Remember, an angle of elevation always starts from the observer's position on the ground, looking up toward the top of the pole. Taking 10 seconds to draw this right-angled triangle correctly is the most important step you will take. Once the drawing is set up, the geometry does the heavy lifting for you. Look at this triangle from the perspective of our 55-degree angle. The height h is directly across from it, making it our opposite side. The 10-meter baseline runs right alongside the angle, making it the adjacent side. Notice the longest side, the hypotenuse. The question doesn't give us its length, and we don't need it to find the height. Because of that, we can completely ignore both sine and cosine formulas. That leaves us with exactly one correct tool for the job. Tangent is the mathematical rule that links the opposite and adjacent sides together. Let us plug our WAEC numbers right into that formula. Tangent of 55 degrees equals our unknown height, h, divided by 10. By simply labeling the sides and crossing out the hypotenuse, you bypass the common mistake of picking the wrong trigonometric ratio. Now, only basic algebra separates you from the correct answer. To get h to stand alone, we need to clear the fraction. We multiply both sides by 10, bringing it over to the left. The height is exactly 10 times the tangent of 55 degrees. When you punch that into your calculator, the tangent of 55 degrees is roughly 1.428, bringing our total height to 14.28 meters. But pay close attention to the instructions. The exam specifically asks for the height correct to the nearest meter. Since 0.28 is closer to 0 than to a full meter, we round down to exactly 14 meters. That matches option D. Your calculator will always give you precise decimals, but if you ignore the rounding instructions in the final step of the exam, that precision will cost you the mark. Let us test this pattern. This screen shows a new problem, a horizontal distance of 12 meters and an angle of elevation of 45 degrees. Pause the video now, draw your triangle, and find the height. Let's check your work. Following our tangent rule, the height equals 12 times the tangent of 45 degrees. Since tan 45 is exactly 1, the height matches the distance perfectly, 12 meters. Let's run a second one, faster. A distance of 20 meters and a 30-degree angle. Height equals 20 times tan 30, which calculates out to 11.54 meters. Applying our rounding rule to the nearest meter, 11.54 rounds up to exactly 12 meters. This repetition turns the drawing process into a mental reflex. The more often you practice these sketches, the faster you will recognize the underlying equation hidden in the text. We can condense this logic into one reliable formula for elevation problems. Whenever you have the horizontal distance and need the height, multiply that distance by the tangent of the given angle. For more step-by-step WAEC, JAMB, and GCE mathematical explanations that cut straight to the logic, rush over to QandAhelp.com right now and make sure to subscribe to this channel. Success in WAEC Mathematics comes from recognizing the repeatable geometric patterns built into the exam questions. Keep practicing, and I will see you in the next lesson.